So we're going to calculate lesson 38. How's that? Okay. Lesson 38, we are delving back into integrals a little bit. And it's a pretty short lesson just because it's two basic integral concepts that you already know the equivalent derivative concepts, so they're, pretty self-explanatory here. The first thing we're going to look at is the integral of a sum. So the idea is if you are being asked to take an integral, so an antiderivative, and there are multiple terms added and subtracted together. So the idea that the integral of f of x plus g of x dx can be broken up into separate integrals. So it's the integral of f of x dx plus the integral of g of x dx. So just going with the idea that when you have multiple terms added or subtracted, when you take the derivatives, you just take the derivative of each individual term. Well, same is true for the integral. When you're taking the integral of multiple pieces added and subtracted, you're taking the integral of each individual term. Okay? There's a little bit of notation I'm going to write out just so you can kind of be familiar with it and see it today. But it's not notation I necessarily expect you to do every time you do an integral problem. Okay? So as we look at example 1, it's the integral of 6s to the 12th plus 5s plus 3e to the s plus 4 ds. There's a typo in the notes that it says x, but notice the problem is in terms of s, so they all have to be s's, not x's, if I can say those differently. So to go with the theme of, okay, integral of a sum here, the idea that there are 4 different terms being added together. So officially what that means is we can break this up into 4 individual integrals. And that's what, again, not that I expect you to do that every problem you do, but that's what I'm going to do just for today, just to understand the equivalence here, is that this can be broken up into the integral of 6s to the 12th ds plus the integral of 5s ds plus the integral of 3e to the s ds and plus the integral of 4 ds. So that's basically what today's rule is saying, is that one big integral can be broken into multiple integrals as long as we're talking about a sum. Now, the one other integral rule I want to kind of review here is a constant. When you have a constant within an integral, what can we do with that constant officially? Do what? So like this 6, it's 6s to the 12th, but that 6 officially can be pulled out front. Again, is that something we write out every time? We don't necessarily think through that. But, just so you can see the notation and everything, this can also be written as 6 integral of s to the 12th ds. So really, all you're going to be integrating there is s to the 12th. The 6 is already there. Plus, on the next one, that means we can put the 5 out front. So it's 5 integral of s ds. Plus, on the next one, there's a 3. So the 3 can be pulled out front. So 3 integral of e to the s ds. And then the last one, there's a 4. You can put that 4 out front and say 4 integral of ds. Again, that's fancy notation. This notation is good to understand what things you can and can't do. Okay, understanding integral rules is what I'm trying to get you to do here. Shall we integrate? Okay, so on the first one, 6 times the integral of s to the 12th. What's the integral of s to the 12th? Maddie's saying something over there, but I couldn't hear it.
No, ignore me.
No.
This is where we have to use a special rule thing, right?
Maybe. I don't know. When we're taking derivatives, what do we do to the power?
Stick it out.
We take the power out front, and then we subtract 1 from the power. That's the derivative. Integral, instead of subtracting 1 from the power, we add 1 to the power and divide by that new power. Does that sound familiar? So if we add 1 to the power, that becomes 13. And then if we divide by 13, you can say s to the 13 over 13. Or we can sometimes put out front as like 1/13 s to the 13th. Keep in mind we have a 6 in there though.
So 6s to the 13.
Yes. Although I just wrote it differently. Okay, so I just wrote 6/13 s to the 13th. Ross just said 6s to the 13 over 13. We're equivalent. Be aware that they're equivalent, right? Carry down my plus sign. 5 times the integral of s. So what do we do here? Add 1 to the power, so it becomes s to the second. And divide by 2. 5 halves s squared. Because it would be 1/2 s squared, and then you multiply by 5, so 5 halves s squared. Okay? Plus 3 times the integral of e to the s. What's the integral of e to the s? E to the s. So this is just going to be 3e to the s plus 4 times the integral of ds. I mean, what's the integral of 4? And it's going to be 4s. And then plus c. Don't forget the plus c. Even though we had all these mini integrals, you have to throw one big plus c at the end. All those pieces coming back to you? I guess I kind of forgot how new our power rule is here. So it's probably a good day to review adding 1 to the power and dividing by that new power. I forgot how new that is.
I think we did it last week.
We did it last week, but it just I don't think we've had a lot of practice with it.
Right after that.
Yeah, exactly. Okay, shall we practice with example 2? It's the integral of, there's 4 things added together there, right? I'm going to go ahead and write it out, my separate integrals. Again, just today for the practice. I probably won't after today. I'm also going to go ahead and pull out my constants as I go in the first step this time. So the integral of 6 sine u, so I'm going to say 6 integral of sine u du plus, I'm going to pull out the 5 and say the integral of u to the -5th du plus, I'm going to pull out the 3, and it's the integral of e to the u du, and plus integral of 2 du, so I'm going to pull out the 2, and it's 2 integral du. Okay. 6 integral of sine u du. -6 cosine u. The 6 just stays out front. And here's what you have to think, okay? So if we take the derivative of cosine, the derivative of cosine is normally negative sign. So if we're integrating a positive sign, we have to have a negative cosine there. Okay? Plus, there's a 5, integral of u to the -5th.
So that would be 5 over -4.
Okay? So u to the -5th, when we add 1, becomes u to the -4th. So then you're dividing by -4. And so it's like a -1/4 or u to the -4 over -4. We've also got a 5 out there though. So how am I going to put this together? So -5/4 is what I would write here. Or yes, plus negative, whatever. You guys know the equivalents. 3 integral of e to the u du.
3 to the
Okay. Integral of e to the u is still e to the u. Plus 2 integral of du plus 2u. And don't forget, plus c. Okay, questions there? Okay, let's go to the next page. Or next, I guess it's the next page for me, not for you. The other part of today, so we have integral of a sum, which is just doing the integral of each individual piece, and the integral of 1 over x. Yeah, and this is one of the special cases that you just have to memorize. Okay? Notice it says recall the following. The derivative of the natural log of x is 1 over x. So if the derivative of the natural log of x is 1 over x, that means the integral of 1 over x is natural log of x. And that should say not equals c, plus c. I was too for a brief moment. I was like, what? The integral of 1 over x dx equals the natural log of x, which equals c. Sorry. No, that's a plus c. That's a typo. Yeah, I have it in there. Okay, so that's just a memorization one, right? You know the derivative of natural log of x being 1 over x. So recognize when you see 1 over x, you're trying to do an integral. And I will tell you, well, okay, let's talk about example 3, and they'll throw that comment in at the end. So the integral of all of that. I'm not even going to bother reading it. I'm going to write it out in separate integrals today just to go with the flow. And I'm going to pull my constants out front. So as we write this first one, the integral of 4 over t. There's a constant I can put out front there, yes? So what I would suggest is you can put that 4 out front as 4 times the integral. If you factor that 4 out front, it's then 1 over t dt. Are we okay with that? Plus 3. I put the 3 out front, integral. T to the negative 1.
So this gets interesting. Because if you leave it like it is there, you get a denominator of 0, right?
Right, and this is where, okay, so this is how I kind of remember the rule, is in the form 3t to the negative 1. Like if I leave this, and I'm going to change it here in a moment because I don't like that. Okay, but if I leave it as t to the negative 1, and my brain does not process that at that moment that it's actually 1 over t. So, okay, the rule is we add 1 to the power, right? If you add 1 to the power, negative 1 plus 1 is 0. And that's where my brain says, oh, whoa, whoa, whoa. I'm not supposed to get 0. I'm supposed to get a number. Oh, this is 1 over t. This is the natural log of t. Okay, so when you add 1 to your power, you should never get that power of 0. Because when you get that power of 0, that is your special case of natural log. Does that make sense there? That's my signal. I don't know what you guys want to come up with or whatever, but like that's my signal because I've done it on occasion. Where I'll add 1 and I'm like, oh, duh, it's t to the negative 1. That's 1 over t. I need to not think of it as adding 1 to the power. I need to think natural log. Okay, yes?
Okay, so if it was like t to the negative 2 or negative 3, that'd be fine because it doesn't equal 0.
Yeah. Because anytime, any other power other than negative 1, you always add 1 to the power and divide by that new power. Every other power. It's just the negative 1 is a special case. And it's because you then get 0, which then takes us to a constant, but yet it's not supposed to be a constant, and yeah. Okay? So, if you catch it, you can take t to negative 1 and rewrite it as 1 over t dt. If not, when you go to add 1 later, hopefully it will trigger that, wait, why did I get 0? Okay? So let me finish writing this out. Plus 4 times the integral of cosine t dt, and plus 3 times the integral of sine t dt. The rest of this is all fairly obvious. Okay? So on that first one, we took that 4 out front, which just means there's a coefficient of 4. What's the integral of 1 over t? Natural log of t. So I'm going to say 4 natural log of t. Plus, and again, this is where we've already talked, right? If we go to add 1 to that power, we get a 0 and then we're confused. That's when your confused brain needs to click, oh, natural log, got it. So plus 3 natural log, absolute value of t. Okay. Integral of 4 cosine t. Okay. The derivative of sine is cosine, so it just stays the same. Sine. So plus 4 sine t.
Minus 3 cosine t.
Minus 3 cosine t. The derivative of cosine is negative sine, but we don't have that negative here, do we? So we put our negative on the original and say minus 3 cosine t plus c. Multiple choice would likely not have it in this form. 4 natural log t plus 3 natural log t is 7 natural log t. Just saying. That's a good trick there. Okay. They would probably add those and say that, oh, hey, this is 7 natural log of t. Plus 4 sine t minus 3 cosine t plus c. Just a friendly thing to look out for there. And as I thought, that's my notes for today, isn't it? Okay, so good integral review. Let's talk homework.